So the topic for this particular video will be principles of software design. So if you remember in the previous video, I explained you how at certain times we'll have to compromise with the design principles in order to ship faster. While we were building TUF Plus, we compromised on a lot of best practices. We avoided a lot of design principles because the goal was to go live as soon as possible, right? So sometimes we'll have to take a call if we want to follow the design principles now, or maybe we can implement them later. But then in this video, we will be talking about certain principles that are non-avoidable. Like we will be following them no matter what because they're very simple and you can follow them. This will help you to keep your code clean. This will help you to make sure that you ship faster as well. 3 principles. The first one is the dry principle. The next one is the KESS principle. The next one is the Yagni principle. Let's understand the first principle, which is the dry principle. What is that? Do not repeat yourself. I think it explains itself, but still I'll read out the definition. It means that each piece of knowledge or logic should have a single unambiguous representation within the system. What do I mean by that? Imagine you're writing code, right? And you have a function 1 at some package. You also have a function 2 at some like package directory, folder, whatever you want to call it. And inside both of the functions, you're writing a logic that is same. For the easy explanation, let's take the example of odd and even. Very simple. Imagine you're writing a logic like if n modulo 2 equal to 0. And in this function 2 as well, you wrote the same logic. So over here, what I'm saying is, this is the same logic and this is the same logic. And we are writing it in 2 different places. So that's a repetition of code. That's a repetition of knowledge. This shouldn't happen. So what typically you should be doing is, you should be extracting this particular logic out into a common place. And from there, you should be using it. For an example, what you could do is, you can make a util class and you can extract this particular logic. Again, for the sake of understanding, we're taking this simple code. We have it under the util class. And what we could do is, instead of, writing the same logic at both places, we can straight away use it from the util class. So this is what dry principle is. Again, it's very easy to maintain and you can always follow the dry principle. Do not avoid it because it will not be taking a lot of time. Perfect. What is the importance of dry principle? I think most of you know it from the definition. Like, if we are not repeating ourselves, that means we will be removing redundancy. That means the same piece of code being at multiple places. Doesn't make sense. So we will be reducing redundancy, right? Easier maintenance. What do we mean by that? Now imagine this logic is changing. Certain things will change in this particular logic. Now, if I had to do a change in my previous code, I'll have to do a change here, I'll have to do a change here, and I'll have to do a change at every place where this logic was implemented. But then, if I follow the dry principle, I can just do the change here, just at a single place. And eventually, because I'm using that logic across my code base, I do not have to take care of the other places. If I do the change at the central place, everything else will be taken care of. That is why it's easier to maintain. Understood? Single point of change, as I said, just do at one place and it is maintainable across every place. Got it? Perfect. Again, when I'm talking about maintenance, if I have to remove from here, I don't want to use it. I can just remove it from here. So it's extremely easy if you Do not repeat yourself. Otherwise, imagine a humongous code base. Just imagine it's a huge code base, right? And there are, let's say, 15 places where the logic is being implemented. There might be a time where you do changes at 14 places and you miss out at one place, and that will break one of your feature. Got it? It's important that you follow this dry principle. Perfect. How do we apply the dry principle when we are coding? Please identify any portion of repetitive code. If you're saying, okay, this code is here, this code is here, this code is also here, that's when you identify it and you put it in some common place, or whatever design you're following, you can do it. Got it? Next, extract common functionality. If you see that there is a certain common functionality, you can always extract it on a parent level. What do I mean by parent level? If there's a package and inside that there are files, and each of the files have a common functionality, so what you could do is, on this particular level, you can add that functionality, and that functionality can be used across all the files under this parent. Very simple, pretty simple if you're into coding. Perfect. What's the next thing? Leverage libraries and frameworks. For an example, again, I'll take the easiest of examples just to explain you the point. If I'm asking you to find the power of 2 to the power 5, one of the ways is, you write a for loop for 5 times and then you do 2 into 2 into 2 into 2 for 5 times. That is one of the ways. But then again, this is where you can use the existing libraries, because that will make your code readable. If I'm writing something like math.pow 2,5, it's readable. Again, it's a very simple example. This can be extended to, using different libraries which are doing bulk of the work, tough work. So it's important that you leverage the libraries and framework that is already there instead of writing the code yourself. When you're new into the software industry, you'll have this thing that I'm going to write everything. I'm literally going to write everything. Remember one rule, that is, never ever reinvent the wheel. There's no point. Focus on your use case. You have certain use cases that you're working on. Focus on that. There's no point in focusing on the other things. For an example, I'll give you a example that you can relate to. So when we were building TUF Plus, we needed a payment gateway. Was there a point in building that payment gateway by ourselves? No. That's when we leveraged something like a Razorpay, something like a PayPal, something like a cash-free payments. Do not reinvent the wheel. Instead, leverage the libraries, framework, or any particular third-party stuff that you can have. Got it? Perfect. Refactor code regularly. What does that mean? As I said, while we were building TUF Plus, we had the code shipped, everything is working fine, the system is very stable as of now. But this is the time, because the code base is small, I can refactor the code base component by component and make sure that the code is in a much better shape so that I can scale the code. So it's very important that if you have shipped fast, if you have done mistakes, do not, just keep the mistakes at a corner. Revisit them and try to refactor them. Find out some bandwidth from your, engineering time, and then try to refactor the code regularly so that while you scale, it's easier for you to scale. Understood? Perfect. Next question. When not to use the dry principle? Should we always use the dry principle? No. In certain cases, you can decide to skip it as well. First of all, premature abstraction. For an example, you're writing a code, and then you'll have to do a lot of changes in order to extract out the common logic. That's when you say, maybe I can just skip it. It's not necessary unless and until you see a major chunk of code. Something like, I give you the example of odd and even. There's no point in extracting that, right? So something as small as that, you can decide to skip. It's not necessary that you always get into abstracting everything out, then there will be a bunch of classes and you will find it difficult to maintain. So it's important you focus, and if you feel like, okay, this is worth extracting out, that's when you do an abstraction. Perfect. Performance critical code. Imagine the code is already written by someone, and it is, for an example, again, let's take TUF Plus. We have a compiler and run and submit buttons. This is most like, a primary, use case. This is one of the biggest use case that we have. We have code on the backend. Now, do I refactor it? We need to be extremely careful. Why? Because it is critical. It's used by everyone, literally. So if I'm doing a change, I'll have to be extremely careful. So maybe I can avoid it as of now because it's working fine. Or if I'm doing a change, then I can follow a certain different way in order to implement it, which we will be talking about in the later stages. But please avoid, doing changes to critical code unless until you are absolutely sure, because if you're breaking something, that might impact revenue, that might impact customer experience, and a lot of other things. So it's not always like, okay, I need to follow low level design. No, sometimes the other things like customer experience and revenue do take a center stage. Sacrificing readability. Imagine you're writing a function and literally you have abstracted everything. There's a function call here, 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 there's a function call here. There's no code there. So what that means is I have to go here, see what's happening. Then I have to come back, go here, see what's happening. Come back, go here and see what's happening. Next, go here and see what's happening. That is too much of dry principle. So sometimes if it's not readable, do not abstract it, because there might be a lot of things that's happening inside a common logic, and if you extract it, it might get difficult to read around. So got it? When do you avoid a dry principle? Legacy code. What is legacy code? Something that's written years back, something which you are not comfortable with. Avoid it. Don't be smart enough. Okay, I'm gonna refactor it. Unless and until you have proper permissions or proper instructions from your manager, from your tech lead, do not touch the legacy code. There is a reason why we call it legacy code, because it's working, it's running fine in the production, and we are not going to touch it, because touching it can impact performance, can impact revenue, can impact customer experience, can literally impact a lot of things. It's very important that we avoid legacy code. Dry principle is a principle that you should be following when you are writing the code. Got it? Refactoring is okay, but be careful. Perfect. So we know about the dry principle as of now. What is the next? Yeah, the KISS principle. It is not the one that you're thinking of. Keep it simple, stupid. Yes. A formal definition. A design should be kept as simple as possible. Do not overcomplicate things. A lot of times we think, okay, I know a lot of design principles, I know about object-oriented programming, let's put classes everywhere, let's put interfaces, let's put a lot of layers. No, keep it simple, stupid. Keep it readable. Don't overcomplicate unless until it's extremely important. Understood? So design should be kept as simple as possible. Complexity should only be introduced when absolutely necessary, because whenever you are abstracting, whenever you are introducing object-oriented programming principles, or for that reason design principles, you are kind of increasing the complexity of the code, because you're going to break it down into classes, interfaces, and a lot of other parts. That is introducing complexity. Tomorrow, if someone is coming across, it will take time. It will take time for him to understand. Got it? If it's very limited stuff of code. If it is very limited stuff of code, avoid getting into that thing. Instead, just keep it simple. Just keep it simple. It's okay. It's not necessary that you always, get into that zone. What is the importance? Again, easier debugging. If everything has a separate class, everything is well defined, just gets easier to debug. I know where to get across. If tomorrow in the TUF Plus the run breaks, I know I'll have to get into the run method, and that's where I'll figure it out. And if the run method is huge, if it's broken into parts, I can easily figure out, this part is working, this part is working, this part is working, and eventually I can figure it out. So the debugging is extremely easy. Perfect. Improved readability. Again, pretty simple, straightforward. Better maintainability. Again, you can always maintain it easily. You can scale it. You can sunset features. You can introduce features. Faster development. If you have multiple developers, you can say, okay, you're going to work at that component. You can work at this component. So there will be very limited intersection of code changes. So it's going to be easier to develop as well for you as well, because you'll be able to read the code. You'll be able to understand the code. You'll be able to, insert new code into it as well. That was about the KISS principle. Perfect. So we know about the second one as well. What is the last one? The Yagni principle. Let's understand this. Okay, you aren't gonna need it. That is what the Yagni principle is all about. So a formal definition, I'll get into this. But if I have to give you a definition around real life, we have TF+, right? So as of now, we have payment gateways. And the payment gateways typically support, UPI, credit card, debit card, a lot of other things. But if I'm implementing this and I think, okay, tomorrow, or maybe, 3 months down the line, I'm going to have crypto as well. And for that reason, I'm going to implement the code that handles crypto payments as well. Does it make sense? No, because if I'm going to implement the code that handles crypto payments, it's going to take time. It's going to, push the release date, because now I'll have to write the code, I'll have to test it, and eventually that will take some time. So it's very important. You aren't going to need it. You're going to follow this principle. If you're not needing it now, park it. Do it whenever it's needed. Got it? So something like a crypto payment, whenever we will be bringing it, maybe at that time I can code it up, I can test it, I can deploy it at that phase. As of now, is it important? No, I can skip it. I will write code, whatever is needed. That's it. Got it? Perfect. So again, let's come to the formal definition. Always implement things when you actually need them. Think you can relate it? Never ever when you just foresee, like that it's gonna come, but not now. So do not foresee that you might need them. Perfect. Tomorrow crypto might get banned. At that point, I'll not be requiring it. Got it? Perfect. What is the importance? Reduced waste. Now imagine I implement code which is handling crypto payments, and tomorrow the crypto is getting banned, or for some reason I decide that I'm not going to introduce this particular thing. Now, there is a code which is in our code base which is not being used. I can call it as waste code. It's not being used in the production. So I'll again have to remove it. I'll again have to submit a new PR in order to remove it. So that's a waste code. It's going to again take development time in order to remove it. So it's important that you do not have a lot of waste code in that. Simplified code base, we only have things what we need in production or whatever is needed. Perfect. Faster development, obviously, because if you're not developing the things that are going to be required in the future, we're going to be faster because we just develop the things that are needed and we ship it, because shipping is the king. Like if you're going to write millions and millions of lines of code, but if you do not ship it out, if you do not bring in revenue, nothing matters. You can be the best coder in the world, but if your product is not getting shipped out, it doesn't really matter. So you'll have to balance it out as well. When not to follow? Do I always need to follow this? No. You already know the requirements. For an example, as I said, the crypto payments. Imagine I know that crypto is coming across. So what I could typically do is, whenever I am defining the payment layer, I can say UPI layer, I can say credit card layer, I can say debit card, I can say multiple other layers, and I can have the crypto layer as well. I'll not implement it as of now. I can just have the layer. I'll not implement it. I'll just have the layer. It's because I know that this is a requirement that will come across. I can have the layer in the design, but maybe I'll not implement it now. Whenever it's required, I'll implement. But if I have the layer, if someone tomorrow is reading my code base, he knows in payment we are supporting UPI, CC, debit card, and there's a crypto that's not implemented. So it's going to be easier for them to, just implement it over there. Otherwise, if tomorrow someone comes up and he has to implement the crypto, he'll have to figure out, okay, where to implement. So there's a lot of things over there. So if you're really aware that, okay, this is something which we are going to do right after this one, or maybe, there is scope around this, you can have it in your design layer. You can leave the implementation for the later half. Performance critical areas. If you see that you're going to do an end-to-end test, like completely going to do an end-to-end test, and you feel it's better to write the code as of now, because let's get it tested properly and let's ship it, so that tomorrow when we enable that feature, we're fine. We don't have to retest it and do all the other things. So if you feel that that particular code is a tough portion of the code, it's going to be, again, it's going to take time. Tomorrow I'll have to read through it again to implement something. And if you today I've read through it, I know, I'm confident I can write it, go through it. Because tomorrow, if after 2 months you're trying to implement it in the same code, in the same place, it might take time, because you'll again have to go through it. It's a critical code. It's critical codes are tough to read, are tough to break into. So it's important. If you're confident, if you're like, okay, I'm going to take once and I'm going to just implement it, just go ahead and do it, right? Now, these principles, again, are very subjective. Whatever I'm teaching across LLD, they're very, very subjective. It's not any, thumb rule that you're going to follow it. You might have a different opinion. I might have a different opinion. Understood? It's important to respect each other's opinion, and it's important to take away, whatever knowledge I have, whatever experience I have. At the same time, you can always, give your comments across below so that I can go through that. And yeah, this was it about the second one. Let's meet in the next one. Till then, thank you.